Alright, so this is Unit 9, Lesson 1, talking about radicals. I borrowed these notes from Miss Elaine Hill, so, Elaine, if you see your notes, I am giving you credit for it. Now, radicals. Here is the terminology that we really need to focus on, okay? The radical symbol, which is this symbol right there. The index is the number in front. If the index is not shown, it's always assumed to be 2. And the radicand, which is the number inside the radical symbol. Okay, so we need to know those things. Now, in order to find out what's going on here, let's talk about here. Okay, if I have an index of 3, that means I'm looking for groupings of 3. If I've got an index of 2, I'm looking for groupings of 2. So I take the number 64, break it down into its factors, and come up with groupings of, break it down into the smallest thing. So I know that 4 times 4 times 4 equals 64. And since I'm looking for groupings of 3, I leave it like that. And I circle that grouping, and the grouping comes out, and it's a 4. Okay. For right here, 2, the radicand symbol is the index is not shown, so it is a 2. And we take the 2 and we take 169, break that down into its factors. That's 13 times 13. And the square root of 169 is 13. Okay, over here we've got we've got negative 27, and we're looking for the factors of negative 27. So it's negative 3 times negative 3 times negative 3. And since we're looking for groups of 3, we can go ahead and circle all these guys, and it equals 3. Okay, over here we can break 4 down into negative 2 and positive 2. Well, there's no way that combination works out. We cannot take the square root of a negative number. You can't take the square root of. You can't take the root when the index is a even for a negative number. Okay, so over here we've got 32 to the 5th power. So we take 32, break it down to its factors of 2, 2, 2, 2, and you notice that's a grouping of 5, so you can go ahead and circle the entire grouping. The answer is a 2. Okay. 0 to any index power is always 0. Okay. And now we've got 81 here. Okay. Negative 81, I break it down into its most common factors, and there is no way we can, again, take the root of a negative number when the index is even. So the answer is no real root. Okay. Over here we got the index of 4, which is an even number. So we break 16 down into its basic roots, which is 2, 2, 2, 2, and take the take the grouping of that. We get the number 2, and then the negative is on the outside. We get that. Okay. Simplifying perfect radicals. Well, I can take this 3 squared and write it as 3 times 3, right there, and then take the square root of that, and again, that's an index of 2, so we need a grouping of 2. The answer is 3. Over here, I can write this as x times x. We've got the index is a 2, so we take the grouping of 2, and the answer is x. Same thing here. Got a grouping of 3. Okay, index of 3, so we write down negative 5 3 times out, and the grouping is a negative 5 on the outside. Again, if the index and the power number over here match, they just go ahead and cancel out, and the answer is the radicand right here. Okay, so the radicand is a plus b to the 8th power. Again, the index and the power cancel each other out. You're left with that. Okay, over here this makes it really kind of hard. So what I do is I factor this thing out to x plus 1 and x plus 1. I can write this as x plus 1 squared, or I can say that this is a index of 2, and I circle the grouping of 2, and the answer is x plus 1. And again, just as over here, if the index and the power are the same, they cancel each other out. It doesn't matter which order they're on. Got the index and the power are the same, they cancel out. The answer is 5. And here's another way of looking at it. Okay. Next page. Okay. Non-perfect radicands. Okay. Over here, 24. Well, 24 is not a perfect square or perfect cube, so what I do is I break it down into 2 factors. Okay, we're breaking down to its most common factors. Okay, 4 and 6, and then I can break 4 down into 2 and 2. 6 becomes 2 and 3. I'm looking for groupings of 2 because the index is a 2. Circle that grouping of 2. That 2 comes out. Well, the 2 times 3, there's nothing I can do. It's not a grouping of 2. So that stays inside and I multiply back. Okay, 80 is a 8 times 10. I can break down the 8 into 2, 2, and 2. The 10 becomes a 2 and a 5. Again, I'm looking for groupings of 2 because the index is 2. Grouping of 2, grouping of 2. Those guys come out. This grouping of 2 becomes a 2. This grouping of 2 becomes a 2. The 5 stays on the inside. And I finally multiplied the 2 times 2 on the outside to equal to 5. Over here, I've got the radicand of 16. So I've got 16 broken down to its most common factors, 2, 2, and 2. And I've got an index of 3. So look, I'm looking for a grouping of 3. I go ahead and circle the grouping of 3. And that comes out. That 2, which is not circled, stays over here. Keep the index, and the 2 comes out from that grouping. Okay, 48. Again, same thing. Break it down. 6 is 3 and 2. 8 is 2, 2, 2. Circle the grouping of 4. That comes out. The 3 stays on the inside. You're good to go. Okay, simplifying special radicals. Okay, sometimes we can't get this, so I take the index and I break it down to a 2 times 3 or a 3 times 2. And I can go ahead and split that as a radical inside a radical. Okay, and I know that I can take the square root of 81, which is 9, but the rest of this doesn't work out. Okay, so I can break the index down into things, then I can work this out as much as possible. So look, 8, the factors are 1 and 8, but you don't want to use that, so you can use 2 and 4 or 4 and 2. Okay, I know I've got a square root of 64, so I can go ahead and change that. Now I can flip it around so I can have the square root of 64 and 4 on the outside, and the answer would be this. Okay, so 12 would be a 4 and 3 or a 3 and 4. I know I can do a cube root of 27, but there's no fourth root of 27, so I put the 3 on the inside, the radical 3 on the inside, so the cube root of 27 is 3, and I can't do much with the index of 4, so I just leave it there. Okay, again, 6 is a 2 and 3 or a 3 and 2. Again, I can also do the cube root of 64, which is 4, right? So I write it like this. Cube root of 64 is 4. Wait a minute, square root of 4 is a 2. So you keep going. In the radicand, if both of them are larger, the index is closest. Okay, there we go. I do apologize for this thing zooming in and out. Not sure exactly how to control it, but this is a first time run on this, so you guys will have to deal with it. I do apologize. Okay. The only other way for me to get around this thing zooming in and out like that, or focusing in and out, would be for me to leave it on the smallest thing, and I won't be able to zoom in, which would make it even more difficult for you guys to read, so we're going to kind of have to deal with it. Okay, over here, got a index of 2. We got x to the third power, so I write out x 3 times. Okay, and I circle the pairs of 2, the grouping of 2. Okay, that comes on the outside. This x, which is not circled, stays on the inside. Okay, or I can change it to an x squared times x. And again, square root of x squared is x, and that comes on the outside. Okay, this one right here, I can write out x 15 times, or I can write it, since I'm already looking for groupings of 3, write them in groups of 3. X to the third, x to the third, x to the third, x to the third. Well, wait a minute. All of those come out, so all those x's come out, and it's x to the 5th on the outside. Okay. The other way of thinking about this is 3 goes into 15 how many times? 5 times, so x to the 5th comes outside with nothing else on the inside. Okay. We're going to do that one this way. 4 goes into 12 3 times, so a to the 3rd comes out. There's nothing left over. 4 goes into 9 twice, so b to the squared comes outside, and b to the 1 stays on the inside because the remainder of 1. Okay, 4 does not go into 2, so c squared stays on the inside. Okay, so let's try this out. That's a radical of 2. Okay, we take the 12, break it down to 2 times 2 times 3, and the 2 times 2, that 2 comes out there. The 3, which is not circled, stays on the inside. Okay, now the square root of 2 right here. Okay, so it's square root and 5. 2 goes into 5 2 times with one left over, so 2 x squared on the outside, x to the 1 on the inside. Okay, back over here. 2 goes into 6 3 times, so y to the third comes out, no remainder, so there's no y's on the inside. Okay, 2 goes into 1, well it doesn't, so z stays right there. Okay, again, when we're doing with the stuff, with the numbers, okay, let's break it down into 2, 2, 2, 2, 2. Okay, circle a grouping of 3, bring that out, that 1 remaining 2 stays right there. Okay, now with the variables is much easier. 3 goes into 12 4 times with nothing left over, so a to the 4th comes out. Okay. 3 goes into 5 once, so b to the 1 power comes out, while the remainder of 2 stays there. Okay. 3 goes into 10 3 times, so c to the 3rd comes out, with the remainder of c to the 1 on the inside. Okay. Multiplying radicals. Okay. We can multiply as long as the indexes are the same, must have the same index, as you guys can see, must have the same index. Okay, so the index is on the outside, and I can multiply them on the inside. So I know 18 is 9 times 9, sorry, 2 times 9, and 9 is 3 times 3, so that's 2, 3, 3. That stays on the inside, and now we're looking for a grouping of 3. We circle that grouping of 3. 3 comes out, the 2 stays on the inside. Okay, again, the important part is if we have the same indexes, the numbers inside the radical, or the radicands, can multiply, and the coefficients on the outside will multiply. So over here, we get 2 times 5 is 10 right there. The negative 6 and the 4, which are inside the radicand, which are the radicands with the same index, multiply together. Okay. So we've got this. We can say it is negative 24, right? So we can break this down as 2. Negative 2 times negative 2 times negative 2 times 3 gives us that negative 24, right? So we circle all those negative 2's, those guys come out. Okay, the 3 has no grouping piece, so it stays right there. And 10, which is from the 2 times 5 times the negative 2 gives us the negative 20. Okay, over here, index is the same, so we can go ahead and multiply the insides, the radicands. We just break them down right away. 4 is 2, 2. 8 is 2, 2, 2. Okay, I'm looking for groupings of 4, so I go ahead and circle 4 of those 2's. That group comes out with a 2. This one stays inside. Okay, right here. We write this entire thing out twice because it says the entire thing twice. So the outside numbers multiplied equal to 9. The inside two numbers changes to a 4. But wait a minute, I know the square root of 4, which is a 2, so the answer is 18. Okay, indexes are the same, so that's great. Okay, let's put everything under one big index grouping right here. So the negative 4 stays on the outside. Okay, I'm going to break the 8 down into negative 2, negative 2, negative 2. Okay, the 16 is 4 of those 2's. So again, I've got all those guys lined up. I'm looking for groupings of 5. Okay, that comes out. Negative 2 comes out. Okay, now over here, the way it's written is a negative 1, and that comes out when it's an odd. Okay, if it's odd index, the negative 1 can come out. If it's not an odd index, it cannot come out. Okay, so now, easiest way to take care of this is, for the variables, 5 goes into 5 one time, so x to the 1 comes out. 5 goes into 10 twice, so y squared comes out. Okay, 5 does not go into, well, right there, so it stays right there. Okay, next page. And again, I'm trying to go through this kind of quickly. Okay, dividing radicals, just take this radical symbol, put it over the entire thing. Instead of having two radical symbols, just make one big radical symbol. So that I can say 75 divided by 3 is 25, or the square root of 25 is 5. Okay, the coefficients on the outside, we can deal with that. 18 divided by 6 is 3, so that stays on the outside. And I take, since the index is the same, I can take this entire radical symbol and make it 80 divided by 5, which is 16. So we simplify a little bit. Now I can take that 16 and break it into 2, 2, 2. Circle that grouping of 3. That comes out into 3 times 2, that 2 stays inside when we've got 6 radical 2. Okay, again, the coefficients, we can just go ahead and simplify that to a 5. 27 over 3 is a 9. And again, we simplify this. Got x's on top and bottom. Okay, we got more on the top and 3 more on the top. The y's cancel out. Okay, now that's how we're talking about square root. Square root of 9 is 3, that comes out. Okay, 2 goes into 3, which is the 2 is the index right there. It goes into 3 one time, so that stays there with 1 remainder. And then we simply multiply everything out, and we get this right there. Okay, again, since the index is the same, get that. 144 divided by 3 is 48. Again, we simplify this, k to the 4th and m to the 6th. Now we can say, we can break that 48 down into 2, 2, 2, 2, 3. Okay, and the grouping of 4 comes out. Okay, we can say 4 goes into 4 one time, so k to the 1 comes out. 4 goes into 6 one time with a 2 left over, so m to the 2nd stays on the inside, and m to the 1 comes outside. Okay, adding and subtracting radicals. Again, the rule is pretty much the same. Okay, must have the same index. Okay, now when we have the same index, we can go ahead and pretend this is like an x. Okay, 2x plus 5x is, well, 7x. But instead of the x, we've got a radical 3. Okay, this, the way it's written, cannot work, so we need to simplify this and simplify this. So we go ahead and simplify 54 into 3, 3, 3, 2. Okay, we simplify the 5, stays right there. We break out the grouping of 3, comes out. Okay, and the 2 on the inside. We break down the 16 into this, that comes outside. So now when we look at it, we've got cube root of 2, cube root of 2. So this is the same. So now all I do is work with the coefficients. 15 minus 8 is 7, the radical of 2. Okay. Again, all these, we need to simplify this. I simplify 32 right there. Simplify 20. Simplify 72. Okay. Now we get, select the groupings of 2, they come out. So 32 becomes 4 radical 2. 2 radical 20 becomes 4 radical 5. And 72 becomes negative 6 radical 2. While the ones with the same radicals, with radicand, it's got to have the same index and radicand, we can go ahead and add their coefficients. So it's negative 6 and 4, we can get that as a negative 2. One with the radical 5, can't do much with it, so that stays by itself. Okay, same over here. Simplify each of these. So we have a b index of 4 c radical. Okay, again, we have the same radical and index, so we can go ahead and add their coefficients. So b plus 3b equals 4b. This stays the same. Okay, multiplying binomials. Okay, FOIL, you just take this, multiply. This one's a distribution problem. Okay, so 5 times 20 is 100. If 5 times radical 5 times 3 is radical 3 5. Again, we know the square root of that. That's 10, so we can write it like this. This one we FOIL. Okay, 5 times 4 is 20. 4 times negative radical 2 3 is negative 8 radical 3. Go through the same process. Look, we got the radical 3's right there, so we can add their coefficients. Okay, that works out. This one right here, that's a square root of 9 is 3, multiplied out. And again, combine like terms, and we end up with this. Okay, FOIL, we get all this. Okay, square root of 36 is 6. Now again, when we're FOILing, the last term will work out to be a single number. Okay, so the 54 minus 25 gives us that, and then this. Okay, 15 radical 6 minus 15 radical 6, well, those two cancel out, so the answer is just negative 29. Okay. To save time on the video, you guys can look at this really quickly, pause it, and then work it out.